earth, windy, sunny. The objective: to design a new version of the Neudeflat in Utrecht, Netherlands, with the earth, wind and fire as sustainable factors. The existing building. The existing floor plan. The first step is to remove the existing facade. We then strip down the building of its structure and create a new structural system. We keep the building floor height, the building footprint, shape and orientation. The new construction is a streamlined steel construction. We then add a new facade, which is a double skin. Meet Windy. Windy provides our building with natural ventilation. Let's follow him on his journey through our building design and see how we make sure Windy is our new best friend. Air is blown on the top of our building. By having inlets in all wind directions, negative wind pressure never disturbs the air inlets. Also, the downward pressure provided by the climate cascade is never disturbed. The inlets lead the air into the climate cascade. Water droplets released at the inlet push the fresh air down and provide continuous air pressure. So even without wind, the system works. While air falls, the temperature droplets heat or cool the fresh air downwards to approximately 13 degrees Celsius. So air is blown into the top of our building, climatized through the climate cascade. At the bottom, a basin collects water. Due to the pressure, the air is pushed upwards again through a second shaft. At every floor level, air can be regulated into separate intercircling shafts within our double facade. The shafts in turn are connected to our hollow floor system, through which air is able to flow freely. Regulators divide the air over the floor. Instead of letting the air go up and out of the building, we make it go down first. Exhausted air will flow out of our building through a centrally placed atrium. And where where does the air come down? The air goes through into the basement towards the solar chimney placed on the facade. How and why does this happen? Meet Sunny. In the solar chimney, sun heats up the air inside. Sun heat adds extra positive pressure by means of the solar chimney to benefit natural airflow. That needs to happen on the south facade in order to get optimum sunlight. The exhaust of the double facade is also connected to this chimney. So in summer, when the solar chimney works best, the heat is effectively dealt with. In winter, the connection is closed off, so that air can provide insulation within the double skin facade. The heated air will be saved by the heat exchanger. The warmed up air can then be used to heat up the building in wintertime. A venturi roof on top of the building ensures that the solar chimney has extra suction. How do we know this works? References. The shower tower. An excellent example of the shower tower is the CH2 Council House in Melbourne. The floor system. The floor system we use as our reference is the slimline floor concept. On the top floor, there are air distribution outlets. A floor heated system is tucked away. A hollow steel beam construction allows the system to have ducts within. A ceiling is placed below, and there is a possible chance for cooling to be placed underneath. The solar chimney. Again, we have used the reference of the Council House in Melbourne as an excellent example of a solar chimney. Finally, we have Ben Bronsema, the creator of the earth, wind, fire concept, from which we have devised our construction and our building of the new Neudeflat. The next step.